and specifically we'll start with maybe let's start at A. We'll do a couple of these, okay? Okay, so here's what it's told us. I would make a list of knowns and unknowns, right? X-intercepts. If I see x-intercepts, what's that talking about? Which form of the parabola am I talking about? X-intercepts. Where do I get x-intercepts from? Factored form, thank you. Okay, so y equals, I'm just going to write this here at the top. As soon as you've made that identification, you're going to write it. Y equals ax minus s times x minus t. And then it told us, over here on the side, you're going to write down things like one of the x-intercepts is 4. So s is equal to 4, and t is equal to -2. Then it told us the y-intercept. What is a y-intercept? It's a point, 0, and -24. So I have an x and a y. X equals 0, y equals -24. What's the one thing I don't know in that question? A. Solve for it. Okay, so you just start plugging stuff in. -24 is equal to A, I don't know, 0 minus 4 multiplied against 0 minus -2. -24 is equal to A times -4 multiplied by 2. And then you rewrite the equation. So it's y equals 3x minus 4, x plus 2. Done. 4 marks. I'm going to ask you one of these somewhere. Right up?
How did you go from -2y to -24?
Say that again? No, sorry, it's -24 the whole way.
Oh.
It's the y-intercept. You just missed that part. Yep.
So this is just for finding the x-intercept?
This is if right off the top they provide you with the x-intercepts. You can do the exact same thing every single time depending on the information that they tell you. So we're going to see in the next question. Let's just jump down and I'll do 4 in a particular way. Okay? Or sorry, 4C, sorry. The second C. Okay? So let's look at, we can call it D if you want. So it gives us the graph over on the side, right? It wants us to determine the equation. Yes, Ella?
For 4a, are we supposed to do the equation in vertex factored and standard form?
Oh, sorry. Yeah, I just did the equation, yeah. You guys have enough information now. You want me to do that? Sorry. So there it is in factored form, right? Sorry, I'll finish that. Thank you, Ella. Okay, there's factored form. It wants it in all 3, right? So let's write it in standard form. Ooh, this is a good question, actually. Okay, how do I get from factored to standard? Just expand. So just expand it. So y is equal to 3. And then I'm going to distribute on top of there x squared plus 2x minus 4x minus 8. Y is equal to 3. X squared minus 2x minus 8. Distribute the 3 in. 3x squared minus 6x minus 24. Does that make sense? Where's that minus 24 from? That's not magic. Like, that's not a, oh, look at that. Like, that's there for a reason. Where did that negative 24 come from? What's it say in the question? What's the y-intercept in the question? Zero, negative 24. That's the y-intercept. We can see it spitted out in standard form. Right? Now, is everybody okay? Those are kind of, I would say, the two easiest based on the question. The third one, we got to write it in vertex form. Okay? Could be a little tricky. You could do it one of two ways. It doesn't matter to me. What you can do is you have both of these things now, right? You have both forms of the parabola. You have standard and you have factored. What you can do is go from standard to vertex, which a process which we've done, or you could go from the factored form, find the middle, the axis of symmetry, plug in the axis of symmetry into the equation, get the y value. Now you know the vertex and you know the a value, and then it's done. You do it one of two ways. I think most of you are probably going to want to complete the square. Okay, so let's complete the square, because that's how we switch from standard to vertex. Okay. Okay, so I'm going to backtrack a line, right? And I'm going to write out the 3x squared minus 2x minus 8. Oh, no, let's not do that. There's my bad habits again. Okay, I'll just write out the equation again, and then we'll start from scratch. Okay, 3x squared minus 6x minus 24. Now I'm going to factor. What's the first rule? It's complete a square. You got to factor out the number in front of x squared because it's got to be 1, right? So y equals 3. When I do that, I open some square brackets. X squared minus 2x. Close the square brackets. Throw the number on the end to the away. Okay. So now the next thing is find the z value. Z is, and be careful with this, a lot of people were doing z as negative 6. It is not negative 6. It is the negative 2. It's the number after you removed the 3. So z is negative 2 divided by 2 squared, which is equal to negative 1 squared, which is equal to 1. So 3, open the square bracket, x squared minus 2x plus 1 minus 1, close, minus 24. First 3 become a perfect square trinomial. We're going to get x minus 1 squared minus 1 minus 24. Distribute the 3 in. That's a good question.
How did it start again? Can you scroll?
It just, yeah, it's number, right, if you have your review, it's number 4A, if you got your review. I don't actually have, I can scroll all the way up, but this is just kind of me doing work underneath the review.
In quadratics?
In the quadratics, yeah. 4A in the quadratics. So basically wanted just to solve for the equation given that it gave us the x-intercepts and the y-intercept. Tobias? Yep. Does anybody have any crazy concerns? That's a good question from like a specific process perspective, right? We got a few different practices there. Now, what's the one thing that I notice about all three equations though? What's the a value in all three of them? Did it magically somehow change? It's 3. kind of cool. Right. Okay, it's a good question. Now, if I were to just briefly, I'm not going to do this whole question again, but if I just took a look at, if I look at, we'll call it D, okay, so the second C that's on your sheet, we've got a graph. Okay, maybe I'll scroll up here, okay, and we'll take a look at it. If I give you a picture on the test, you can look at the picture and read off points, right? I can look at that and go, oh, there's the vertex. There's the y-intercept. There are the x-intercepts. Okay? You just do the question the exact same way. Except this time you have a little bit of freedom because I didn't explicitly only tell you the x-intercepts. I told you the vertex too. So let's go down. What's the vertex in this question? -2 and -4, right? Does everybody agree? Okay. So let's say the question gave you a vertex of -4, -2, -4. Let's go down. Okay. Let's say the question gave us or said vertex was -2, -4. But it also told us other information about the graph too, right? Like let's say the y-intercept. What was the y-intercept in that question? Oh. Yeah, 0 and -3, right? Same thing, except this time it gave us different information. What did it tell us? Told us the vertex. Am I going to write factored form on my page for this question? No, I'm going to write vertex form because it told me about the vertex. So just write it down. Y equals ax minus h squared plus k. How do we read the vertex off of that equation? Here's h and here's k. That's how you guys read vertices off of the equation, right? So let's just fill that in for here and here and do the exact same thing. You have 4 pieces of known information. Solve for A. The exact same question, just in a different form. Just give you different information this time. Right? So let's just solve it. Y equals A. I'm going to fill in the information first, and then I'll go, well, let's just fill it in right off the top. -3, 0 minus -2 squared minus 4. So I'm going to get -3 plus 4 is equal to 4a. 1 equals 4a. A equals 1/4. Rewrite the equation. These questions are actually, I would say this question, because I'm thinking, is easier than the question we just did above. For the reason of, they just gave us more information. I could very easily, now that I know what the A value is, and I told you that the A value cannot change for that, it's all the same A value. You now know what the A value is. Why can I not go back to the question, or the picture, and identify from it the 2 x-intercepts? You know A has to be 1/4, so why can't I just write y equals 1/4 x minus 2 x minus plus 6.
What if you're not giving the graph though?
That's an issue. Then it's the first question that we did, where you got to expand and factor, or like expand and complete the square. You just got to use the processes that I've taught you. If you're given the picture, that's like an ideal situation. I could ask you for all of them now, right? Because now there's your equation in factored form. We can go and expand that and get it in standard, and we're done. We have all three forms. Yeah, Retta.
If you were to not have your x-intercepts, right, and there's no picture, and you were to have it in vertex form, can you just use your square root, like, formula thing
Yes.
to find the x-intercept?
Yes. Okay, let's talk about that. Let's get, this is all like, what great questions that we're like doing today, because what Retta said, Retta says, okay, I want to solve, like, I have this equation now, and you guys have seen this, and your question is, I need to write it in factored form. So if I write something in factored form, I'm looking for x. Does everybody agree? Okay, I gave you a method. This is a great question. I gave you a method to solve for that. It's called the root method. Right? And what Retta said is, if I don't have the picture, I could use this process and solve for it. So, what is the y value? What is the y value when the graph crosses the x-axis? 0, right? So if I draw this, the y values here are 0. So you say, okay, 0 equals 1/4 x plus 2 squared minus 4. You're going to solve for x and see what happens. Bring 4 over. It becomes 4 equals 1/4 x plus 2 squared. Right? Multiply both sides by 4 because of the 1/4. So I get 16 is equal to x plus 2 squared. Right? Now I'm able to what? Square root both sides. What happens when I square root things? I have to write plus minus. So I get plus minus 4 is equal to x plus 2. Then I just subtract 2 from both sides. So I get negative 2 plus minus 4. So you get these are x equals, don't forget that. X equals negative 6 and x equals 2. So if I were to rewrite these, those are my x-intercepts, s and t. You rewrite it. Y equals 1/4 x minus negative 6 x minus 2. And then these two here, the two negatives make a positive. What a fantastic question. This is big picture stuff now, right? Like, I've given you the skills to solve for that. Now you're staring at your quadratics flowchart and you're thinking, okay, I know how to do all this stuff, right? Hopefully. Right? Quadratics, it's just switching between those three forms. That's the only reason why we show you all that stuff. Switch it between those three forms so that you can answer different things under different scenarios that I'm asking you for, right? Each of those gives you different information that's important or pertinent to specific things, right? If I ask you about the max, like optimization or maximum or minimums, you better tell me about the vertex. So you better write it in vertex form, which is why we did completing the square. If I ask you about how far something went or how long it took or the break-even points, Financially, that's factored form because you're answering questions about where it crosses the x-axis. That makes sense? And standard form is is virtually useless unless you're asking for a starting value. How high was the ball launched from? It's just the C value. Make sense? But it's the pivot. Like it's the equation that you pivot through to get to the other two. Okay. Any questions? You could continue that and write it in standard form by expanding one of those two. Okay, and then you're done. That's that question done.